All right, I'm going to take a look at some trouble questions from practice set 91 to 100. The first question that seemed to be an issue is actually this question right here, number 91. In this question, it's just talking about doing a rotation of 180 degrees about the origin. When it says about the origin, that's simply telling us at that point, the origin is basically going to be the point that we would pin this particular shape at. Now, remember, 180 degrees makes a straight line. So if I was to take a look at this point, I know that after the rotation, this point has to go from there all the way around to here, which is a half of a circle. So this point would become right there. Now, looking at that, we can eliminate a couple of these options. This one would not work, and this one would not work. So 180 degrees brings that point to there, which makes this a possibility and this a possibility. However, we could also look at another point. If we look at this point and we go 180 degrees, that point has to also create a straight line or end up down here, end up down here to make this a straight line, if you can envision that right there. So we'd have this and this and this and that right there to create a 180 degree rotation. So the correct answer would be D. The next question I want to look at is number 94. This was the most challenging question. I think the best way to do this is maybe just to use a little common sense and draw a picture. So what we have is we have 2 bottles of ketchup in the freezer. Here's the first one. It tells us that the second bottle is twice the size of the first one. So I'm going to draw the second one roughly twice as big, just to kind of give you an idea that the second one is larger. It says the first bottle of ketchup was 1/3 full, which would be about right there. And the second bottle of ketchup was 2/3 full, which would be about right there. Now, the problem it tells us, we're going to take this bottle and we're going to dump it into that one. And the question is, what's going to happen? Are we going to overflow? Or are we going to be 2/9 full, etc.? Well, if you look at this bottle right now, this bottle right here started at 2/3 full, which is greater than 1/2. So I know that if I dump that into it, I'm still going to have more than a half, and 2/9 is less than a half. 1/2 would be exactly half, which would actually mean that this volume would decrease, so that doesn't work. If we had the same size bottle, we would need an extra 1/3 here, but because this bottle's smaller, we really don't actually have a third of this. So this 1/3 in a smaller bottle is not going to fill it up. In fact, it would only be half of what we need because it's half as small, so it would bring us to right there someplace. So we're not going to be overflowing. We're not going to be completely full. The only answer that would possibly work, even just thinking logically here, would be 5/6 full. So the answer is C. All right, the next one I want to look at is number 96. This is a good review on our very basic distance, rate, time formula. So anytime we're talking about travel, we're going to have distance is equal to rate times time. What I'm going to do here is I'm going to first start by looking at this first set of information. Kayla's first trip, she went 200 miles, which is the distance. We don't know her exact speed, but we know it took her 5 hours. So what I want to do here is I want to figure out how fast was she going in this first trip. So I'm going to divide by 5 to find her rate, and we end up with a rate of 40 miles per hour. So in the first trip, she's going 40 miles per hour. Now, it says, what happens if she averages 10 miles per hour faster? So what I'm going to do is I'm going to take this 40 miles per hour. I'm going to add 10 miles per hour for a new speed in this trip of 50 miles per hour. Now, we have to cover the same distance. It's going to say how much time could we save if we cover that same distance of 200 miles. So I'm going to use that distance, rate, time formula again. Distance is equal to rate times time. Our distance still needs to be 200 miles. But in this case, the rate is not going to be 40, but 50. And the question is going to be, how long is it going to take us now to go 200 miles going the 10 miles per hour faster? So to solve this equation, we divide both sides by 50. And when we divide by 50, we end up with exactly 50 miles per hour. Excuse me, not 50 miles per hour. We divide by 50 on both sides, and we end up with a time equal to 4 hours. So the time it would take her if she was going that extra 10 miles per hour would be 4 hours in comparison to the 5-hour first trip. So by going 10 miles per hour faster, she would save exactly 1 hour of time. The answer is D. Very important concept. Remember, when travel problems, we can use distance, rate, time in multiple ways to find missing values. The last question deals with fractions and equivalent fractions. It simply wants to know, what can we do to both the numerator and denominator in this case to end up with 1/2? Well, I guess my first piece of advice would be to look at 7/9. We know that 7/9 is greater than 1/2. So if I want to get this fraction down to 1/2, I'm going to have to take some of this away. So in this case, what I'm going to do is I'm going to just subtract 5 from both. Now, when we add or subtract fractions, typically we have to have common denominators, but that's really not what this question's asking. It's just saying, what can you do to the top and to the bottom to end up with exactly 1/2? So if I subtract 5 on top, I have 2. If I subtract 5 on bottom, I have 4, and 2/4 is equivalent to 1/2. So the answer is G.